Alright guys, we're going to start the tutorial session. Today I'm going to give you a brief introduction about how you should do for the lab 2. Uh, okay, let's take a look at the lab menu here. Alright, give me a second. Sorry about the delay because this is my first time using the the Blackboard virtual classroom. Um, Alright, so can everyone see the lab menu here? All right.
Yes.
Okay. Um. So for this lab, because you guys have already done the lab 1, I'm not sure if you guys have finished it, but for this lab, you are supposed to find a transfer function of this theta m over vm from the transfer function you derived for lab 1. And for this system, for the new transfer for function, you are supposed to design a phase or lead or lag controller to achieve these requirements here. And in this plot, this upper loop is actually, I'm not sure if you guys want to use the Quasar Virtual Lab, but in this loop, this one is also is still the virtual system, and this one is actually for the loop where this block is actually where you can put the transfer function for the system, which is this transfer function, and this block, which is the same as this block, is where you can place your controller. Uh, so just the hardest part for this lab here is that first you have to find the correct transfer function from omega m of over vm to this. And I mentioned that here, since this omega mt equals to the dot theta mt, the corresponding Laplace transform is actually omega s equal to s theta s, which means in order to find this transfer function, you just have to substitute the transfer function for lab 1 with this. I think it is quite clear. And after you find the transfer function for this one, you just have to place the transfer function here and then design a controller that satisfies this requirement here, and you run a simulation, it will give you the results, and you can see from the scope whether the controller you designed meets these requirements. So this is basically the the object for your lab 2. And Dr. Chen mentioned that you can either do this one or just do the lower loop. So I think this is quite clear. And I prefer, if you guys have any questions, just ask me here, because I think many of you have like sorts of problem for the last lab, and if you can ask your questions here, probably everyone else can have a chance to know, like can we understand how we can do lab without Quasar? Okay, so if you don't want to use a Quasar virtual lab, you just have to neglect the upper loop, this loop here. Just cancel this. Just like don't place any of this in the Simulink loop and get rid of this. You are not going to use a Quasar virtual lab. Okay, so just um, leave this part and the lower loop here, then you can do the lab without the Quasar virtual lab. Yes, neglect the Quasar overall. So for lab 1, can you show us which one we don't include? Uh, for lab 1, can you show us which one? So we would have just one input. Yeah, you just have one input on the scope. Um, does everyone here want me to go over lab 1 as well? Okay. Neglect game. So I also have the lab menu for lab 1 here. Um, all right. So for this lab, you should derive the transfer function from of the system omega m s over vms v with the equations I provided here. You just have to do the Laplace transfer function and substitute I. Let me see. Substitute torque m with kt times ims. You just have to do the Laplace function, then substitute this with this. You're going to get the transfer function for the system. And once you for lab 1, you don't have an option of just using the MATLAB. So you have to do this, which the same thing. The upper loop is actually the virtual system, and the lower one is just the transfer function for the system. And once you derive the transfer functions for the system, you just have to put the transfer function for the system here. And keep everything here exactly same as the blocks in the plot. Um, these are the configurations of the settings. Probably many of you guys have already done it, so I don't have to go through that. I think that's every detail I had to tell you guys for this lab, because I think it's quite quite straight as well. The prof said we don't have to use Quasar for lab. I'm not sure if the prof said this. I'm going to confirm with Dr. Chen, but if you don't have to use Quasar for lab 1, the same thing here. You don't have to have the upper loop in the simulation. You just have to have the input here, have the transfer function here, have the output. Get rid of this hardware part as well, hardware block as well. Yeah, I think someone mentioned here you guys have to use that in lab 1, because for lab 2 and lab 3 you have the option of not using that. For the step 1 we need Boolean plot for both server. Yes, basically, all right, for step 8. Okay, since the upper loop and the lower loop is actually the same thing, because you have the transfer function for the system, and I'll tell you guys how this works. So basically, let me zoom in a little bit. So this right block is actually so this signal generator here sends the data to the right block. Then the right block will actually give the system an input signal of this. And this read encoder actually reads the data from the virtual server lab. And the gain and the transfer function here actually converts the readings from the Quantum Virtual Lab to actually the reading here will be counts And these things here, they will convert the counts into radians, which guys you might want for actually radians per second. You guys might need for this lab. So basically, that's how that works. All right, you guys have a lot of questions, so I can only go through one by one. Yeah, so for step at U8, you need body plot for you just need the body plot for the transfer function because you cannot obtain the body plot for the virtual system because body plot only body plot the transfer function here. For this thing here, there is no transfer function. In between these two blocks, it's the real system. The MATLAB cannot analyze the system with just data. So you can only body plot this one and then compare the results of the upper loop with the body plot you obtained for this transfer function. For lab 2, could you show us how to get the setup working without the upper part? Alright guys, okay, so I have the MATLAB here. Just give me a second because I opened that. I think it's curves and the point does not have corners. Alright, I'm just going to show you guys how you should create the Simulink without the Quasar stuff. It's pretty easy. I can teach you guys once, but I will not no longer show you guys how to do that. Um, yeah. Let me see if it sticks. Alright, so for the question I mentioned, how you create a Simulink file without the Quasar mode, Quasar virtual server, you just have to click the Simulink here. It might take a while to pop up. Okay. I'm sorry guys, for my wooden computer, it might take a while. So for lab 2, if you want to do that without the Quasar virtual lab, you just have to open Simulink, this window here, and click the blank model. And all you have to do is that Yeah, I'm not using the remote desktop. No, you don't have to create the Quark hardware I/O model because if for Lab 2, if you choose not to use the Quantum Virtual Lab, it has nothing to do with the Quark hardware the hardware model. Oh, shit. No, yeah, for Lab 2, because Dr. Chen mentioned that you have an option of not using the Quantum one, so you just have to create like a very normal Simulink model, then place the transfer function into the block in design controller. Ah, shit. Um, are you going to give us 5 marks each for first lap? I try to reopen the Simulink. I think the marks for labs are actually 10 for each lab. So if you just want just 5, you should know that. All right, I just try to reopen the Simulink. Oh yeah, now it pops up. So for lab 2, if you want to use just the Simulink, you just have to, let me see the signal generator. Okay, so let's say we have the transfer function block here. You just have to search transfer, okay, and drag the transfer function here. Um, okay, you click on that and typing the transfer function you derive. And now I have two. I'm having two. So let's say the transfer function you derived for lab 2 is just 1 over S1. You just have to place that here. You just have to change the coefficients to get the transfer function you derived for lab 2. And you type in signal generator. Yeah, the signal generator to have the correct like, and then modify the signal generator to have the input you want. Because for lab 2, you guys need to track a step input. Um, it seems that I don't have the step here, so I'm going to use that step. Um, yeah, so I have if you search for the step, you are going to have the step here. And let's click on that and copy paste another transfer function. This transfer function, this transfer function. So let's say this one is actually the controller, and this one is actually the system model. You just have to connect all of this. I need to add a substructure here. Okay, so I'm gonna have an adder here. Change the sign here. And I have a scope there. All right. So that's basically the settings for Lab 2 here. You don't have to go with the Quark target file, hardware file, anything like that. You just have to place your controller here, your system model here, and the step input here, the scope here, then run the simulation. That's just, I think that's just Lab 2. Yeah. So I think, is it clear for you guys? Yeah. But the only hardest part is that you have to derive the transfer function. Like I said, for Lab 2, because um, for Lab 2, you are supposed to get this transfer function, which is actually partial results of the transfer function from Lab 1. You just have to derive the transfer function for Lab 1, then substitute omega s, which is the upper part, with this. And that's just Lab 2. All right. So some of you guys asked me how should I write the report last time, and I think there is no common format, but I can tell you guys, probably you guys have to have the objective, the procedure, the data, like your observation and data, then your conclusion. I would consider 4 parts would be enough. It doesn't have to be very long, but just make sure you write all your observations clearly. Um, Sorry I missed this, but do we have to derive the transfer function? Like I said, for Lab 2, because um, for Lab 2, you are supposed to get this transfer function, which is actually partial results of the transfer function from Lab 1. You just have to derive the transfer function for Lab 1, then substitute omega s, which is the upper part, with this. And that's just Lab 2. All right. So some of you guys asked me how should I write the report last time, and I think there is no common format, but I can tell you guys, probably you guys have to have the objective, the procedure, the data, like your observation and data, then your conclusion. I would consider 4 parts would be enough. It doesn't have to be very long, but just make sure you write all your observations clearly. Um, Sorry I missed this, but do we have some design method for a process for getting the controller transfer function? I think in Dr. Chen's class note, there must be a design method telling you how to get the controller transfer function. Yeah. Any other questions? You can still email me if some part of Lab 1 or Lab 2 is unclear to you. Yeah. Um, okay. I'm not sure. First, I'm not sure if you guys can do lab one without Quasar, but if it is an option. You guys just have to follow the same procedure here. Um, or just give me a second. So all you have to do is that you get rid of for lab one. You just have to get rid of the controller part, connect that, get rid of the feedback part, and change this to a sine wave and run the simulation. But this system model has to be the transfer function you derived. And if you want to do that without the transfer virtual lab for lab one, that's the only thing you have to change here. I think it's pretty. The controller can we use PID? No. For this lab you have to use the phase leader lag controller. Yeah. Torrent cancer. Um, you don't have to include the server in the report, right? You don't have to. You don't have to include the server in the report, but I don't think it will spin in like full circles. If you let's say if you have a sine wave, the output of this for of the system for lab one should be a sine wave as well. If you are making that spins in a full circle, there might be something wrong with your setup or something like. Okay, if the scope shows a sine wave, then that is correct. Yeah, so for lab one, I'm having two functions graphed and compare them, or one only. It depends. If you want to do that, decide to do that with a controller virtual lab, you're going to have like uh, uh, you are going to have at the scope you're going to have two signals and you should compare them because they are actually the same thing. The transfer function and the virtual system should be the same. So for lab one, if you are using Quasar virtual lab and for the output you're getting different signals, that means your the transfer function you derived should be wrong. Yeah, if you decide not to use the virtual lab for lab one, I'm not sure if that's an option. Then yeah, you just have to uh, follow the structure I just showed you earlier. For lab ones. So if you are just using the transfer function, you can still compare that with the body plot. Let's say, for example, okay, so if I run the simulation here, oh, sorry, it's a step. It must be something wrong. Mm. Alright, so I have the sine wave, I have amplitude, I have the frequency of 1, and I have the system. So if I body plot this system, let's say the system mu equal to 1 and dn equal to 1, 1, and then I body plot that. So, G equal to transfer now then body G All right, so if I have a transfer function of this system here, all right. So if I have the transfer function, why am I studying the right? All right. So if we have the transfer function of this one here, and let's say from the Bode plot, you can see that if I have a frequency of shit, of 1 raised per second, the system gain for this one is going to be -5 dB, and the phase lag here is going to be 45 degree. And so if I run this simulation here, hmm, okay, it might take a while because my computer is very slow. Mm. So if we compare the input and output, you can see that the blue one is actually the input, and the yellow one is actually the output. You can see from the plot actually the output between the input and the actually the gain here for the output is probably 0.7. And if you calculate that number here, which is 20 log 0.7, it would probably give you the answer of -5 dB here. And this is the actually the objective for lab 1. You guys are supposed to find the gain from these plots. And you can see from that there is also a phase shift for the output. And that phase shift is actually the should also follow the phase plot here. Um, I think it's basically this the answer for lab 1. Is there any question? How to find the phase again, please. All right, so let's say for this signal, you are having a period of almost 6.28 seconds, which is 2 pi. And let's say we can compare the peak here. And from the peak to peak here is actually, I think this is 1.5, and this is 2.5. So the phase shift here is about 1 second. And if you're using 1 over 6 over the period, which is 6.28 times 360 degrees, you're going to get the phase shift. Is that clear? You compare the peak to peak time, find the difference between the peak to peak over the whole period times 360. Then you can get the phase shift here. Is that clear? Yeah. No problem. Yeah, just before everyone leaves, just ask as many questions as possible because probably I'm going to email later back, and I prefer not to email that things we have the tutorial session. Mm. When we design a phase lead lag controller, how do you want us to cause a phase lead, then phase lag to show the controller does a job? All right, so the purpose of lab 2 is like I said, you just have to make sure that your controller can set it. The controller you design can make the whole system satisfies these requirements. Yeah. I think for this lab, you just have to design either a phase lead or a phase lag controller. It's up to you. For the project, I'm not sure because I'm not sure whether Dr. Chen has announced that, but I'm not sure at this moment. Probably you guys have to use a console for the project, but I think we need to solve the license problem. Yeah. Yep. All right. If he said that, yeah. If he said that, then you guys just have to do the same thing here, like I showed you earlier. You just have to create a model, design your controller, then get a feedback, then run the simulation. You don't have to go through the Quark hardware I/O stuff. But no problem. Yep. I'm glad I can help you guys because that also saves me a lot of time. I don't have to spend time emailing everyone. Last question about the phase. The T in the denominator should be the input. I'm not quite. I'm not getting your question D. What do you mean by the T in the denominator should be the input period signal? Um. All right. Yes. The T in the denominator should be the yes, because actually 360 degrees corresponds to 2 pi here. Yeah. So let's say if your signal has a shorter period, your phase lag, the corresponding phase will be different. Yeah, so the t has to be the t in the denominator has to be the uh, input signal period. Actually, yes, the input signal period will be the output signal period, if I'm correct. Use that phase in the yeah. Yeah, no problem. Any other questions? Italy had a question. I think I solved the question, right? Because she mentioned that yes, thank you. So I'm not quite sure. If I missed the question, can you please type the question again? Because I might not be able to find that. Yeah. Okay. If no question, I would probably end the session in 5 minutes. Yeah, just in case you guys just some sudden questions pops up. Yeah, please. I think you have to use Cancer for Lab 1. You can email Dr. Chen about that because I only write lab manuals and the design the lab. I could not decide whether you guys should use Cancer for Lab 1. No, I don't have to do that, man. At 2 times pi over this number, you just have to use MATLAB to calculate that. If that equals to 0.003, then that's correct. Okay. I don't have to. I don't think I have to do that for you. You can do that on your own. Yeah, the content doesn't work. Um, yeah, well, um, I know the license is a problem for you guys, and I like even for me, I have like sort of lots of problem for the license at the beginning. You can you can try that because the reason why I want you guys to use to compare the result from the virtual lab and the virtual system and the transfer function is that you can confirm that with your transfer function whether the transfer function you derived is correct or not, because every transfer function you derived is exactly the same system. So if you are getting the same outputs from the transfer function and the virtual server, then that means the transfer function you derived is correct. That helps you like understand the system better. That's the reason why I designed the lab like this. But since the license is always a problem, so probably you guys can neglect the concept part, and that's better. That's better. Yeah. All right. 2 more minutes. So if there is a question, yeah, I will just end the session. If there is a necessary, probably Dr. Chen will arrange another tutorial session for Lab 2 or Lab 3 or the project. And until then, I will give you guys another tutorial session. And if there's no more question, I just end the session today. And thank you guys for attending this tutorial session. Have a good day.